Okay, hi. We're going to be covering section 8.2 today, where we talk about multiplying and factoring with polynomials. I really like the first part of this review here, just kind of taking us back to what we talked about in the first lesson. So I'd like you to pause, and I'd like you to try 1, 2, and 3 here. Naming the polynomial based on its degree and number of terms. And then when you unpause, the answer will appear because I'm going to pause as well and write in the solution. So go ahead and pause and work out those 3 problems. Okay, there we go. Here are the names for number 1, 2, and 3. So you can check those on your own. Remember, there's a nice graph or table with all the names from the last notes. So I think it's also in your book as well. So that's definitely something you can refer back to if you need to go back and refresh on those a little bit. Now, what we'll do today is talk about multiplying when we have a monomial and a trinomial. And we can also use the distributive property for this, so we'll see some examples with that as well. And that's generally what I do, is use the distributive property. So what we're looking at here is we're looking at a problem where we would distribute that monomial that is on the outside, and we would distribute it to all terms on the inside of with the trinomial. And that's what they did here, is they kind of broke it apart into pieces. So the 3x you have to multiply. Remember, when we're multiplying with exponents, if they have the same base, then we would add the exponents together. If you look here then, it kind of breaks it down. So we would do the first part here, and we would multiply those first 2 together and add the exponents. That's how you get the 6x to the 3rd. And then we would continue there, adding the exponents and multiplying. And then we would put all of the solutions there together to make a new trinomial. And notice it is written in standard form. So we always want it from the largest exponent to the smallest, or the constant. So let's try another one. And again, if you'd like to pause and try it yourself first, awesome. I'm going to go ahead and work through this real quickly. In this problem, of course, we're just going to be using the distributive property to multiply that through to every term. So this would give me 15 n to the 4th power, because I know there's a 1 there. Bring that minus sign down. Then I have 5n to the 3rd power. Bring that plus sign down. 5 times 8, so we have 40n. So there is my trinomial, and we used the distributive property to get that solution. Now, another part of this lesson is we start talking about the word factor and factoring. Factoring a polynomial basically reverses the multiplication process. So when you're factoring a monomial from a polynomial, the first step would be to find the greatest common factor. Usually we just abbreviate that as GCF, and that has to be the GCF of all of the terms in the polynomial. So to factor a polynomial, we'll start by looking for the GCF. In this example here, we want to look at the 8, the 12, and the 16. Now, they write them out in expanded form, what we call prime factorization or expanded form. I generally just think about, what do 8, 12, and 16, what's the greatest number they all have in common? Well, 4 will go into 8, 12, and 16, and it's the largest number. So 4 would be my GCF. But we also need to look at our variable. Here they all have at least one x in common. So I would also have to include that as my GCF. So the GCF for this trinomial would be 4x. And then from that point, we would factor it out. We would take it out of the trinomial. Remember, it's just the reverse of multiplication. So you would put the 4x here at the beginning, and then you would basically take out a 4x or divide out a 4x from each term in the polynomial. And what's left goes inside those parentheses, okay? So let's look at one here. Example 2 wants to know what is the GCF of these 3 terms in this trinomial. So again, if you look here, they listed the prime factors of each term. But like I said, we can see that 5 would go into all of those terms, and it happens to be the largest that goes into all 3. And then I look to see the number of exponents or number of x's I have, and they each share or have at least one x in common. So again, my GCF here would be 5x. Now you can write it out in expanded form if you would like to. That's a perfectly reasonable strategy, but it's not something you have to do if you can kind of look and think about what they all have in common. So here in this next problem, again, if you want to pause, go ahead and pause it here. Try to do the problem on your own first, and then you can see the explanation. But I'm going to go ahead and work through the problem here. So again, I have a 3, 9, and 12. So I'm trying to think about what number do those all have in common. In this case, 3. So I'm going to just have my GCF here because that's all we're finding at the moment. So they all have a 3 in common. And then I look at my variables. And again, the smallest variable is x to the first power. So they at least have one x in common. So I can add that to my GCF. So for this problem, your GCF should be 3x. Now let's also look at a problem where once we've found the GCF, then we can factor that out of the polynomial. And again, here's a nice example that's worked out for you. They showed how they found the GCF by doing the prime factorization. And then remember, you're doing the reverse of multiplication. So you would just think about taking out or dividing out a 4x from each term in that trinomial. So then that part we put in parentheses to show what's left after we've factored out the 4x, okay? So let's do example 3. Again, if you want to pause and try them on your own, great. If not, you can just keep going and follow along. So here, what is the factored form? Again, we want to look first to find the GCF. Think about what they have in common. So looks like 3 will go into 9, 15, and 12. And the lowest exponent is x squared. So they all share at least an x squared in common. So my GCF would be 3x squared. I'm going to write that here. And then what I'm going to do is with each term, I'm going to take out a 3x squared. I'm going to divide it out from each term in the trinomial and write in parentheses what's left. So 9 divided by 3, 15 divided by 3, 12 divided by 3. So we're going to divide all those out first. And then remember, with the exponents, instead of adding, we'll subtract them. So I would subtract 2 from each exponent as well. So x to the 6th and x squared, so that would leave me with x to the 4th. And then I do the same thing here, so I'm left with 5x squared. Divide the number out and subtract the exponents. And then here I'm left with 4, just 4, because the x squared and the x squared cancel each other out there. And I put that in parentheses, and my GCF is always written in the front of the polynomial. So try the next one, pause the video, try it, see how you do, and then come back and check it with me. So hopefully you had a chance to try that one out. I went ahead and wrote in the solution so you can check. There was a little tricky part to this because they all were a negative or minus. So we could go ahead and include that as part of our GCF. So our GCF would be negative 6x squared, and I would take that out, which means I would divide or subtract out that GCF. And so this is what would be left. And remember, you can check by doing the distributive property. If we do the distributive property to each term, we should end up with what we started with, because remember, factoring is just the opposite of the multiplication process, and you can always check that part. Now moving here along, I guess that is the end of our notes for today. So now it's a chance for you to try and get some practice on your own. So look at the website for the problems that you'll need to complete. And I'll see you later. Bye.